Now coming on to the demo. So this is the initialization part of the project. Uh, this helps in making it modular and loosely coupled. By changing variables like vector type, training model, etc., we are able to efficiently compare different methodologies for feature extraction, selection, and classification algorithms. In this project, I've used Word2Vec, implemented with the help of Jensen library and TF-IDF for feature extraction. The classification algorithms use are naive Bayes, SVM, and random forest, which can be seen by changing these variables, for which the implementation is shown here. So like if you want to change the vector type, we can put a TF-IDF for TF-IDF and Word2Vec for Word2Vec. Word2Vec pre-trained is for the scenario where we have already trained the Word2Vec model and saved it, and we just need to load that model, which is saved by this name. And the classification algorithms can be changed by this variable. NB is for naive Bayes, RF is for random forest, and SVM is for support vector machines, and BT is for batteries. There are other parameters as well. That is, for dimension reduction, we have SVD and G square, and some other variables for the other classifications and parameters. Clean review. The clean review function actually takes raw text of the movie review and helps in pre-processing the text. This is the stage where we have raw movie review from IMDb, and we have used beautiful soup, which actually removes any markups from the data, and as a result the method will return into just splitting the content of the file. And we've also removed any other characters apart from the A to Z alphabets. This function also removes the stop words, but only in case where it is required. Like for example, for n-grams we are not using stop words, we are not removing stop words, so this function would this is a boolean function which would only remove stop words if you're willing to. That is for all the other algorithms and not for when you're using n-grams. This is just a utility function, review to double list, that just makes a list of the words. Review to wake. Well, this is the function that actually transforms the reviews into the feature vectors. This takes the words, a list of words that is extracted from the review, and the model trained Word2Vec model, and converts that into the feature vectors. This is the generate review vector function, which actually generates a m by n numpy array from all reviews, where m is the length of reviews and n is the num features. We have used numpy here. So coming down there, for tokenization, we have used inbuilt NLTK English with pickle for tokenizing the data in case of Word2Vec. Now coming on to the if the vector type you're using is Word2Vec, this part of the code will just clean the text and return a clean version of the training and test reviews. And if we're using TF-IDF, it takes the raw data instead of the list that is used in this Word2Vec. So instead of list, we just passed the raw text for cleaning, and this part only does the cleaning of the data. This is the actual part where actually the vectors are generated for Word2Vec or for TF-IDF. In case of Word2Vec, we are using the built-in libraries for generating the models. If the models are already trained, we just load this model using this function, and if the models are to be made, we just train these models using the inbuilt Jensen library and save those models for further analysis. And this is the function that we saw earlier for generating the review vectorizations. For TF-IDF, using the TF-IDF vectorizer from scikit-learn library, and here the interesting part is that we can set the n-gram range here. We have seen that for n-gram 1 to 3, that is for one term, 1:2 3 terms, we get the best results. And this is just when we run this part of the code, we see these logs. For dimension reduction, as we saw that we use SVD and chi-square. We actually use SVD when we are using word to wake for SVMs, because when we're using chi-square for this naive bias, it may give sorry, if you're using SVD for naive bias, it may give negative inputs. So we're not we don't want that, so we're using chi-square for naive bias. So once we have all the models prepared with the feature extraction and selection processes, we use the training models. This is the variable that I use here just for the purpose of demo, so that I can just change this variable here to let you see the results quickly. So there is RF, NB, and SVM that we implement. Uh, this code implements multinomial and Gaussian naive Bayes, and when we actually have just run this code, and we can see the SVM results. This was run for word to wake, and we can see that word to wake generates a CV score of 87.84%. So if you want to change the vector form, we can just change this vector as TF-IDF, and we will not change anything else, and we'll just run this code to see what's the result. As you can see, it is still on the stage of reading the training reviews, and after this it will go into vectorization form. I'll pause the video so that you don't have to go through all of this. As you can see, the cleaning is done and it's now generating vectors, vectorizing for TF-IDF. This is also done, and now the model training. Yes, we have the results now. So we can see that multinomial naive Bayes has an accuracy of 87.23% and Gaussian naive Bayes at 3.628%. We can change and use random forest and see what is the result for random forest now. Since we've already trained TF-IDF vectors, we don't need to follow the same process again. Because earlier we had only word to wake vectors that we for SVM that we used, and we had, therefore when we changed the vectorization method to TF-IDF, we had to again train the model for that. So you can see that OOV score for training forest 82.696. So now again we can just go to SVM, and we can see that what is the score for SVM in case of TF-IDF. In the first thing we saw that for word to wake, the SVM score was about 88%, and now we are training it for TF-IDF. We have not changed the n-gram range here, but if we need to, we can change the n-gram range 1, 2 or 1, 3, and we'll see a different result. And we'll for 1, 3 we have noticed that the efficiency increases for most of the algorithms. Also, when performing SVM, in case of n-gram, using a TF-IDF for n-grams, we are not actually removing the stopwords. So you can see that when we are using TF-IDF vectorizer, this is true, and we're sending actually okay, it's taking time. I think I'll pause the video so that the video doesn't get too long. So now you can see that SVM, the training and the prediction for SVM is completed for TF-IDF, and the CV score is 0.87744. So this concludes our demo. As you can see from the demo that we are able to compare different algorithms with different approach to feature selection and feature extraction methods like TF-IDF and word to vec. Thank you.